Hello, welcome to Element Maths classes. Today, also we are going to discuss about the chapter 1 relation and function. The first problem, example number 1. Let T be the set of all triangles in a plane with R a relation in T given by R is equal to T1, T2, where T1 is congruent to T2, so that R is an equivalence relation. So in order to show for equivalence relation, we should have the three relations. The first reflex relation, second one symmetric relation, and the third one is transitive relation. So here, given T1 comma T2 belongs to R implies T1 is congruent to T2, congruent to T2. T1 is congruent to T2. The way T be the set of all triangles. Let T be the set of all triangles. Set of all triangles in a plane. All triangles in a plane. In a plane. First one we have to show for reflex relation. A reflex relation. A reflex relation is says that A comma A belongs to R for all A belongs to the given set, or T comma T belongs to R. T comma T belongs to R for all T belongs to the given set of triangles. So here every triangle is congruent to itself. Congruent to itself means that R is reflexive. R is reflexive because T comma T belongs to R. Because T comma T belongs to R. Therefore, R is reflexive relation. Second one, symmetric relation. Symmetric relation. Let T1 comma T2 belongs to R implies T1 is congruent to T2. T1 is congruent to T2 as per definition of the given relation. So this implies T1 is congruent to T2 means that also we can write T2 is also congruent to T1. If T2 is congruent to T1 means T2 comma T1 belongs to the R. Therefore, T1 comma T2 belongs to R implies T2 comma T1 belongs to R. Hence, R is symmetric. R is symmetric. R is symmetric relation. Then third one is transitive relation. Transitive relation. Transitive relation says that let T1 and T1 comma T2 belongs to R and T2 comma T3 belongs to R. As per definition, T1 comma T2 belongs to R means T1 is congruent to T2 and T2 comma T3 belongs T2 is congruent to T3. Here T2 and T2 are common. Therefore, this implies T1 is congruent to T3 for all T1, T2, T3 or belongs to the given set of triangles. This implies T1 comma T3 belongs to R. Therefore, R is transitive. R is transitive relation. R is reflex relation, R is symmetric relation, and R is transitive relation. Hence, R is an equivalence relation. R is an equivalence relation. Hence, R is an equivalence relation. Next problem. Let L be the set of all lines in a plane and R is the relation in L defined by R is equal to L1 comma L2. L1 is perpendicular to L2 so that R is symmetric but neither reflexive nor transitive. Given R is equal to L1 comma L2. L1 is perpendicular to L2. L1 is perpendicular to L2. This can be written as L1 comma L2 belongs to R implies that L1 is perpendicular to L2. Perpendicular to L2. Therefore, here first we have to see reflex relation. Reflex relation. Every line is not perpendicular to itself. Every line is not perpendicular to itself. Therefore, L comma L is not belongs to R. Therefore, R is not reflection. R is not reflection. Second one, symmetric. Symmetric. Let L1 comma L2 belongs to R implies that L1 is perpendicular to L2. If L1 is perpendicular to L2 means L2 is also perpendicular to L1. Therefore, L2 comma L1 belongs to R. Therefore, R is symmetric. R is symmetric. Here, for example, this is L1. This is L2. L1 is perpendicular to L2 and L2 is also perpendicular to L1. Therefore, R is symmetric. Third one, transitive. Transitive relation. Let L1 comma L2 and belongs to R and L2 comma L3 belongs to R. L1 comma L2 belongs to R means L1 is perpendicular to L2. Perpendicular to L2. And L2 comma L3 belongs means L2 is perpendicular to L3. But L1 is perpendicular to L2, L2 is perpendicular to L3. This is L3. L1 is perpendicular to L2, L2 is also perpendicular to L3. But L1 is not perpendicular to L3. This L1 is not perpendicular to L3. It is parallel. L1 is parallel to L3. Therefore, L1 comma L3 not belongs to R. Therefore, R is not transitive. Hence, R is symmetric. R is symmetric.